Hi guys, it's Mrs. Blake, and today we're going to take a look at the third part of mole conversions. Today we're going to look at mass to moles. In part one of these videos, we took a look at what is a mole. And as cute as this little guy is over here, and we use him for clip art, that's not what we're talking about when we talk about moles in chemistry. Instead, we defined a mole as 6.02 times 10 to the 23rd. It is a very similar concept to what is a dozen? A dozen is 12. Well, 1 mole is 6.02 times 10 to the 23rd, and we define that as Avogadro's number. In part 2 of the videos, we took a look at converting then between moles and particles, or little tiny pieces, using that 6.02 times 10 to the 23rd. Remember, I can have a dozen of anything. Well, I can have a mole of anything as well, and that's why it's a generic word that we call particles. But in reality, you'll run into the term atoms if we're talking about an element. Pieces of a covalent bonded substance is going to be a molecule. And pieces of an ionically bonded substance is going to be a formula unit. So we can ask you about a mole of anything, and it's still going to be the exact same calculation. So the materials needed for this video are going to be a scientific calculator. Again, if you don't have a scientific calculator, Google scientific calculator, and you'll come up with a scientific calculator that works great for you to be able to use. And you're going to need a periodic table. So for today, we're going to take a look at the next part of this conversion. The next part of this conversion involves mass. And what's the big deal about mass? Well, mass is what we measure in lab. Mass is our lab data. So you go back in any chemistry lab and you throw something on a balance, and your units are going to come out to be grams. But the problem is that for almost every chemistry problem, you need moles. And sometimes for chemistry problems, you need to find out how many little pieces of water there are. So when we take a look at it, you cannot measure directly in moles. It requires us to be able to convert. And this part of the conversion between mass and moles is going to be a critical part of just about every calculation that you do in chemistry. So when we take a look, what do we use to be able to convert between mass and moles? Well, we use a concept known as molar mass. Now, in a previous video, we talked about what is molar mass and what's molar mass. Well, molar mass is going to be the amount of 1 mole of any substance. It's the mass of 1 mole of any substance. But the key part of that is its units. I can use my periodic table to find that carbon is 12.01, but if I use the units grams per mole, that allows me to be able to link my grams and my moles in my conversion. If I find table salt as 1 piece of sodium and 1 piece of chlorine and add it up to be 58.44, again, the units grams connect to my moles, and it provides the link between these two. So let's take a look at a problem and see how this works. So if we take a look at problem 1, it says, how many moles of hydrogen peroxide are there in 1,000 grams of hydrogen peroxide? Now, chemistry problems are all set up the exact same way. They give you a number that becomes your starting point. So if I have 1,000 grams, I'm going to start with 1,000.0 grams. Now, it is really important that you don't just randomly start pulling numbers out of chemistry problems. Take a second and read the question, because there's 2 parts to the question. I'm starting with grams, but my question wants me to find how many moles are in those grams. So I know my end point for this problem is going to be moles. If I'm looking at units and not numbers, then I know that I am going to be starting with grams, excuse me, and I'm trying to convert it to moles. So what am I going to use? I'm going to use my molar mass. But in the second video, we said all chemistry problems can be set up the exact same way. I am starting with 1,000 grams, and I can set up a line. And I don't care what this unit is, I want to get rid of this unit. And so I'm going to put it on the bottom so it can cancel out. And you can basically do that for every problem that you see. Take the number, take that unit, and put that unit on the bottom so it can cancel out. Now we are using the molar mass. And the units on molar mass are grams per mole. So what goes on the top would be the other side. This is the per line, and it's grams per mole. And by definition, it is the number of grams in 1 mole of any substance. So I can put a 1 with mole. And that really only leaves one place for me to fill in, and that's going to be the molar mass of H2O2. This is where my periodic table comes in. So I have 2 pieces of hydrogen at 1.01, and I have 2 pieces of oxygen at 16.00. So I'm going to come out with 34.02 grams per mole. And technically it's grams per 1 mole, but since I've already got that part filled in up here, the only thing I really need to fill in is the 34.02. And because my grams units have canceled, the unit I have left is moles, and that's what I'm looking for. I can calculate this out. To calculate this out, I'm going to multiply anything on top. I'm going to divide by anything on the bottom. And when I punch this number into my calculator, then I'm going to take 1,000. I'm going to take it times 1, and I'm going to take it divided by 34.02. And I'm going to come out with, and 2 decimal places is a nice place to leave it. Let's say 29.39 moles. Number 2 is very similar to number 1. Pause the video and see what you can do with number 2. So how'd you do? Pause the video and check your answer. In number 2, they don't give you the chemical formula. It is really important to use your periodic table to realize that magnesium is a 2+ charge and chlorine is a 1- charge, therefore giving me a chemical formula that is MgCl2. Chemical formulas are really important because if I have the formula wrong, there's no way I can get this problem right. So I started with 148 grams. Grams goes on the bottom then, so it can cancel out. I'm converting it to moles, so I'm going to use the molar mass, which I added up over here. 1 piece of magnesium and 2 pieces of chlorine give me a molar mass of 95.2. It's 1 mole of something is the number of grams, so the number of grams went on the bottom. You multiply on the top and you divide on the bottom, and I came out with 1.55. So let's take a look at the next problem. And the next problem is solved exactly the same, even though it's different. So when I take a look at this one says how many grams are there in 5.0 moles of lead. Now, wait a second, I'm not starting in the right place. But that's okay, I set the problem up the exact same way. This is 5.00 moles of lead. And this time, don't care how the problem's set up, this unit is always going to go down here. So this time when I go up to my flowchart, I am no longer going to be starting with mass. Now I'm going to be starting with moles. And my arrow is going to be flipped in the other direction. I am still going to be using my molar mass. It's just my molar mass is going to flip around on me. If I take a look at problem number 2, moles is on the top. Well, now I want to get rid of moles because I'm starting with moles, and this unit always goes on the bottom. Well, this is still going to be my molar mass. And molar mass says in 1 mole of anything, there are some number of grams, which is going to be my molar mass. This time I'm just dealing with lead. No compound, just lead. So I can use my periodic table to look up the molar mass of lead. So lead's molar mass is 207.2. And I don't need to add up anything because it's just lead. So moles cancels out moles because it's top and bottom. That's the whole concept because my problem wants me to find how many grams. Well, if I look at the unit that I have left, it's grams. And I'm still going to multiply by what's on the top, and I'm still going to divide by what's on the bottom. But this time I'm going to multiply by the 207.2. So in my calculator, I'm going to take 5 times 207.2, and I'm going to divide by 1. And I'm going to come out with, switch my color here, 1036 grams of lead. So problem number 4 looks very similar to problem number 3. Take a minute and see what you can do with problem number 4. So take a look at number 4's answer and see how you did. Again, this problem doesn't give us the chemical formula, so I need to take a look at my periodic table. Potassium is a metal that has a +1 charge, and when I'm dealing with an ionic compound, I have to be very careful that I'm looking at my ending. Nitrate is NO3. It also has a -1 charge, so I end up with the formula that's KNO3. If I'm starting with moles, moles is what goes on the bottom, so it can cancel out, and that puts grams up on top when I'm using my molar mass. Grams per mole can be written in either direction in these problems. So I use my molar mass and add it up, and I come up with 101.11 grams per mole. The 101.11 goes on top. Anything on top is multiplied by, and anything on the bottom is divided by. So I'm going to take 2.50 times 101.11. I'm going to divide it by the 1. And in my calculator, I came out with 252.8 grams. When I'm converting between grams and moles, then molar mass becomes my key to be able to make that conversion. But the key thing with any chemistry problem or any mole conversion problem is watch your units. If I start with mass, grams goes on the bottom to cancel out. If I start with moles, moles goes on the bottom to cancel out. And if I'm using my units, it's going to help me set up these problems. Practice some mass to mole calculations and come back for part 4 where we take a look at two-step conversions. Thanks for watching.